Okay, so hi guys, welcome back to my channel. So this is going to be the third video of Kafka playlist. So in this video, we are going to actually learn about Kafka producers and writing messages to Kafka. Okay, so let's start the video. Okay, so the first question is, how does a message get from our application into Kafka safely, and what can go wrong along the way? How does the message travels to Kafka safely and to the consumers? What is the process? So let's explore one by one. So this is the sequence. What Kafka follows. So going through all these steps may not make sense at the beginning, but I am assuring you that by the end of this, you'll get a clear picture of all these steps. And all these steps will make sense. So just bear with me till the end. So let's start. So the first step is producer record, which is nothing but the actual data. So it is created with a topic, a value, and an optional key, partition, timestamp, and an headers. This is what data contains. The second one is the serializer keys and values to bytes. The key and values are serialized to byte arrays. Why? We'll be seeing very soon. Partitioner picks a partition. If no partition was sent explicitly, a partitioner picks one, usually by the hashing of the key. This is the third step. Record joins a batch. This is the most interesting one. The record then joins a batch of other records headed to the same topic or partition. Let me give you a little bit glimpse. So let's say a producer sent 4 topics. So just because I have already explained you about the partitions, how partition works. So let's say a producer sent 4 messages that is heading towards the single partition. Why? Because the ID of this topics or the message is 42, which is of the same ID, all 4. So instead of sending it one by one, these all 4 messages are getting batched and sent. Did you understand? So record joins a batch and a background thread ships the batch to the broker, to their respective brokers, and the broker replies with record metadata, success or an error. I know that this still seems little vague, but believe me, by the end of this video, you'll get a clear concept. So let's move forward. So a single Kafka producer, whenever we create a producer, a single Kafka producer instance is thread safe. And just because it is thread safe, it is meant to be shared across the threads in an application, not instantiated per thread. Means Kafka producer is thread safe and can be shared across all the threads across the application, and it's not instantiated per thread. Okay. So let's see the first and foremost important step, which is constructing a producer. We'll create a producer by creating a Kafka producer config. Okay. So the first step is @value. This is in Spring Boot. So @value, and we are giving private string bootstrap servers. What is the use of this bootstrap servers? Why we are actually declaring this variable? Okay. Let's see here. So this is the initial contact points our Kafka producer consumer uses to connect to the Kafka cluster. This is the point of contact. Okay. This is the point of contact by which our producer consumers used to connect to the Kafka clusters. You must have doubt that what is Kafka cluster. Okay, so a Kafka cluster is nothing but a group of multiple Kafka brokers that is working together as a unifying messaging system. Okay, I hope Kafka cluster is clear. Now what does this bootstrap server contains? It contains a list of host ports pair that the client uses to make its first connection to the cluster. And once the connection is built, once connected, the client asks that broker for the cluster's metadata, the full list of brokers, which broker is the leader for which partition. All the details will be shared by when the connection is built. Okay. I hope this is clear. Now this is the Kafka producer. We are creating Kafka producer. Let's move to the next page. So what we are doing, we are passing some properties. So this is the generic map that we have created. Inside that map, we have passed this bootstrap server. I hope this bootstrap server is clear. Now the next property that we are passing here is put key.serializer. In this, we have passed string serializer. We have passed value serializer. We are passing string serializer. Okay. And finally, we are creating the Kafka producer with the props that we have created here. Okay. Now let's understand it deeply. So the actual work that happens inside this Kafka producer props is that constructor takes the generic map. This constructor takes a generic map that validates it against the Kafka's own internal config schema. Whenever we are passing the Kafka producer props, the first thing that is going to happen is it will match all the properties with the Kafka's internal config schema, okay, which knows the full list of every config property and producer, that producer accepts, okay, just like the bootstrap servers, key serializer, value serializer, acknowledgements, linger.ms, batch size, and dozens of more. So these are the properties that gets validated for each one. For each property, the schema also knows whether it has a default or not. Some properties, the schema have the default until and unless you explicitly mention those values, okay. Most of them do. Acknowledgement is default, linger.ms is default, compression type is default, but bootstrap server, key serializer, value serializer are defined in that schema with no default. So the constructor requires them to actually be present in the keys, the map we handed it. So if we'll miss one, the construction simply throws the config exception before even the Kafka Producer object even exists. Okay, I hope this is clear. I hope you are clear about all these properties. For this property, we'll go in deep dive further in the video, that why there is the use of this passing the key serializer, value serializers. Okay, so let's understand what property does. So key serializer and value serializer each name a fully qualified Java class. Okay, whatever value we have passed corresponding to key, corresponding to value, is nothing but a Java class that Kafka will instantiate internally, and the call at the moment a record is actually sent. Whenever the producer use this method send record, this is actually record, this is the data, okay, runs before anything goes over the network, before any record goes over the network, Kafka takes the key object and value object from our producer record. So I'll be explaining what is producer record. So when the producer is sending the record, before it actually goes to the network, Kafka internally takes the key object, value object from our producer record and hands each to their corresponding serializer class. Just like, I'll give you an example. It calls its own serializer method, which returns byte array. Only those byte ever leave our application, not the object, not the plain record that we are going to send. Okay. First, that record is getting converted to bytes, then the bytes are getting sent over the network, or that the byte will leave our application. Now let's take a simple use case. I'll take a simple use case to explain about the flow, how the message flow is happening. So let's say we have two services, service 1 and service 2. For service 1, we have the food delivery platforms order service. For service 2, we have restaurant dashboard service. Okay. Now, my point is, let's take a very genuine example, like what a normal guy can think of. Like, this is my problem, this I want to solve, how I can solve it using Kafka. Okay. So I want to send 3 objects: order header events, order item events, and the delivery partner location events. Order header events carry the order header. Order item events carry the order's item. And the delivery partner location events carry the delivery partner's location. So these are the 3 objects that I want to send from this order service. Now, the restaurant dashboard, this service dashboard, which will act like a consumer and this will act like a producer. So this want to send 3 objects. This restaurant dashboard needs to show incoming orders and their items. Restaurant dashboard need to care about these 2 objects. So it needs first 2 topics. This is the topic, this is the topic. Whenever I'll see I want to send 3 objects, I'll be creating a topic. It's not necessary that 3 objects will always have the 3 different topics. I can also say that I want to send 3 objects, but 3 objects is compatible with 1 topic. Okay, this is for the future discussions. So we'll be having these discussions very soon. Okay, so now delivery partner location events, it shows live GPS ping from delivery riders. Did you understand? This carries the order header, this carries the order item, this carries the delivery partner location. Restaurant dashboard only need to care about these 2 topics. Okay. Delivery partner location events, this has nothing to do with the restaurant's dashboard. That data is consumed by completely different service. This data is consumed by completely different service, and that is okay. Something like a consumer facing like tracking service. So finally, restaurant dashboard service never subscribes to it. A restaurant dashboard service will only subscribe to these 2 topics. Let's move forward. Now the next step is the schema registered per topic. So for the order header, if you haven't watched my first and second video of Kafka, please go and watch. There I have explained what is Avro, what is the schema registry, how we can register the schemas, and what is the complete flow that is happening if we are going with the Avro, what is the benefit of Avro over the JSON. So that all is discussed in the first video. You all can go and watch it. Okay, so let's understand which is order header. Order header have the following properties. which is order ID, customer ID, restaurant ID, order amount, total amount, and status. Okay. Similarly, order item has these following properties. Delivery partner location has these following things that it wants to send. So these all configs that we are maintaining inside the schema registry. Now it's time to select the partition. First step what we have done, so we have 3 objects, so most probably we'll be creating the topics out of it. Okay, we'll decide how many topics we want to create. Okay, next one is the schema registered per topic. For per topic we'll be creating the schema registry. Now partition keys. Let's decide the partition keys, because this is very important, and this is the deciding factor how each topic actually gets read. Now the first topic, so for order header events we have decided that restaurant ID will be our key. Why? Because a restaurant's dashboard, in the restaurant dashboard, it is always asking show me my incoming orders. So if we are actually bothered about the restaurant's orders, we want to keep it in a single partition. Okay, it's not like restaurant ID 2 will have all the orders spread out in 2 partitions. Why this is a problem? Why? Because Kafka guarantees ordering inside the partition, not across the partitions. Okay, this is the reason. If you, that's why I'm saying, if you haven't watched my first video, please go and watch. So show me my incoming orders. Okay, so every order for the same restaurant lands on the same partition, whatever I've said just now. Okay, arriving in the order they were placed. I have also given the same example in the first video, which makes clear of all these points that I'm discussing now. So this is kind of a revision. So order item events, the key is order ID. So every item belonging to one order needs to land together. Same as for order item events, same as for order header events. The key is order ID, the key is restaurant ID. For third one, we have the key as partner ID. For one partition or rider's location, ping stay in order relative to each other. Okay, I hope this is clear till now. Now let's see the phase 1, the topic creation. We'll be creating 3 topics. First one is the order header events, second one is the order item events, third one is the delivery partner location events. What we are creating along with the topic is the bootstrap server, which I have already explained, the cluster, which I have already explained, the replication factor I'll be explaining soon. Okay, so just wait. The glimpse I have already given in the first video. Partitions, we are mentioning the partitions 6, but one thing to notice here is why the partition is 12. On what factor we decide how much partition we should keep for every topic. So the deciding factor is location pings get more partitions. Location pings get more partition than orders. Why? Because thousands of riders sending a GPS ping every few seconds. Okay, you need to track the driver where it reaches. Okay, here. So for every second you'll get a message. So is a much higher volume stream than the order placement. So it need more parallelism to keep up. More the partitions, more the parallelism. So let's move forward. So let's move to phase 2, which is nothing but order service producer setup. Now the phase 1, what we have done? We have done the topic creation. Now what we are doing? We are doing the producer setup. So 2 producers, because order data and location data have generally different reliability needs. Okay, order data means we are sending the order header and order item both in this producer. Okay, but location data need to have generally different needs, so we are creating 2 producers. Okay, so for the first producer we are sending the bootstrap server, we are sending the key serializer, already explained, we are sharing the value serializer, already explained. This schema registry URL you need to send. Okay, so as to get the information about the schema registry, whatever we have registered. Okay, I'll show you this one, schema registry. Okay, now the next one is the new one is the acknowledgement. I'll explain you in later part. Okay, the same here, this already explained. This acknowledgement and this linger.ms I'll explain you at the end of the video, then you will have a clear picture. So for now, let's assume that we have created 2 producers. Order header and order items will be sent through order Kafka Producer, and location will be sent through location Kafka Producer. Okay, the reason why we have put 2 different producers is location is looking for acknowledgement is equals to 1 and order Kafka Producer looking for acknowledgement is equals to 0. Why? Acknowledgement is nothing but the replicas are replying to the producer before marking it as success. Okay, why it has 1 and why it has all? Because a lost order is a customer who never get their food. If we lost a particular order, it means that the customer is not going to get the food. Acknowledgement is equals to all is a non-negotiable here. And for the single missed GPS, let's say a driver is sending the location, even if a single GPS is missed, that will be invincible. That will be invincible to anyone. Since another one arrives 3 seconds later, means acknowledgement is equal to 1. Means I don't need acknowledgement from all the servers before marking it as success. That will increase our latency. So this trades a little safety for throughput on a much noisier stream. This is much noisier stream, but this we cannot take the risk, so we have put acknowledgement is equals to all. Now moving further, did you understand this producer record which I have said that I'll be explaining? Okay, did you see this is the producer record? Okay, so let's understand about this producer record, what actually it is. So through the producer record only we'll send the data. Okay, so order Kafka Producer. Here we are passing the topic, we are passing the key, we are passing the content, which is the data, which is the value. Okay, again I'm repeating, this is the topic, this is the key, this is the value. So we have sent header, we have sent item, we have sent the key, we have sent the value, we have sent the key, we have sent the value. Now with the second producer, which is nothing but the location Kafka Producer, we are sending the topic, key and value. Okay, now let's move to phase 3, which will tell the send is called with an order header. Okay, this is called with an order header, which is nothing but the header. Kafka Serializer resolves its schema. Let's see what we have passed. Kafka Serializers, what we have passed inside this header. So when the order header.kafka serializer get called, it resolves its schema against the registry. It will go inside the registry and it will pick all the values. Okay, header. Can you see? It will check for all the fields whether the value is there or not. Now it serializes the object to binary prefixed with dat ID. String serializer turns the restaurant ID into bytes. We have passed. For key, we are passing the string serializer. For value, we are passing the Kafka serializer. So, string serializer turns the restaurant ID into bytes, serializes the object, binary prefix with that ID, which is nothing but doing by Kafka serializer. Okay, value is serialized by Kafka serializer, key is serialized by the string serializer. Now, the next step is the partitioner hashes the key. The partitioner hashes the key. Order header events. Let's say there are 6 partitions. Why? Because at the time of creation we have given will be having 6 partitions. Okay, now and picks one. Let's say partition 4 is selected. Now the record joins the batch already accumulating for partition 4. Let's say the producer has sent multiple times. Okay, multiple microservices has produced some message. Okay, now for partition 4, whatever data is coming, they will get batched, they will get joined and will be sent at once. Okay, now the sender thread ships the batch to whichever broker leads to partition 4. There will be multiple brokers. Which will having the partitions. Let's say this partition. Okay, so let me explain you one thing. Let's say we have partition 1, partition 2 and partition 3. We have this broker. Okay, we cannot rely that the partition 1 data will be only sent to partition broker 1. Okay, no, will be for the safe side, will be sending the partition 1 data to broker 2 also. Okay, so that for parallelism. Okay, now the sender thread ships that batch to whatever broker leads partition 4. Now the broker writes it and replicates it to other 2 replicas. The main broker who is leading the partition 4 will write the message and will replicate to other 2 replicas. Since acknowledgement is equals to all, only then does it reply and the callback to order service fires with the offset. We'll be discussing this. What is this offset? So the broker writes to all the replicas and then they'll reply with a callback that mark it as success. So here is the diagram you can see. So acknowledgement is equals to all, location producer acknowledgement is equals to 1. Order header events, restaurant dashboard. Order item events, restaurant dashboard. This for live tracking services, not this consumer. Okay, not this consumer has subscribed this topic, so it has nothing to do with the delivery partner location. Now let's come to phase 4, which is nothing but the restaurant dashboard consumer setup. Okay, how the consumer side setup works. So we have the props. What we are doing, we are passing the bootstrap server. Same thing. We are passing here the string deserializer, not the serializer. We are passing here the Kafka deserializer, Kafka deserializer. Okay, schema registry URL, which is the same, Avro reader, which is the same, and the group ID, which is nothing but the restaurant dashboard service. Now, when we'll do consumer.subscribe, we have subscribed to order header events and order item events. Now, when the data comes, consumer is continuously polling in the fraction in the interval of 500 millisecond. Okay, now the consumer is constantly polling in the interval of 500 millisecond, and whatever records that we are getting in the format of string and object, what we are actually doing, reader.value, if it is an instance of order header that we have passed, then store.save header we have called this in order to save it in our DB. So if a record value comes as an instance of order item, we are storing the save item. This is the another operation. Let's say this gets stored in the save header DB. This gets stored in the save item DB. So we are identifying and we are storing it respectively. Okay. Now let's move forward. Now what will happen? Kafka Avro deserializer reads the schema ID. They'll read the schema ID for each message. For each message, they will read the schema ID and they will resolve it against the registry. They'll go to the registry. They'll find that, okay, order header items will have these many values. Order items will have these many values. They'll resolve it. Typed order header and order item. No hardcode guessing about which class has a given topic carries. Okay. I hope till here it is clear. Now what is the correlation gap? Okay, which is the most important that I have already explained in the video 1. Let me explain you one more time. Order header and order item travel on two separate topics. So Kafka ordering guarantee within the partition, not across the partition. Okay, so there is no guarantee that real within the one partition of one topic, it says nothing about the header arriving before its own items. Let's say header item is getting carried, order item is getting carried. Okay, there is no guarantee that the header item will reach first, then the order item. No, it's not the case. They both will occur. That is the guarantee that the Kafka is giving inside that partition. Reordering guarantee is also given by Kafka inside that partition. But across the partition, that who will reach first, that entirely depends on the network. Okay, so that has nothing to do with the Kafka. So that is the correlation gap. Now let's understand again on that order service, few more people have joined. 3 more employees have joined the order service team and they want to publish 2 more things. The first thing is order audit log for the tracking status change, for the cancellations, for the refunds, for an audit trail for the order recycle. Okay. The second one is the delivery metric, operational number like preparation time, pickup delay, delivery assignment latency, all the things they want to send. Now what are the steps they need to follow? So the first thing they need to do is the schema registry. They'll register the schema. 2 things they want to send. They want to mention what are the fields they are going to send. They'll be creating the topics for which partition is 6, partition is 12. For delivery metrics, they have declared 12 partitions. Metrics are much higher volume streams, so it goes more partitions and for parallelism. Okay. Now, does the producer code need to be changed? No. Why the producer code doesn't need to be changed? Order Because whatever 2 things that we are going to send lies under 2 producer that we have declared. The first one is the order Kafka producer in which we are going to send the orders, and the second one is the location Kafka producer which we have declared at the beginning. Okay, so the 2 things that we are going to share is order audit log that fits under the producer that we have declared, delivery metrics that fits under the producer that we have already declared. So there is no producer change needed. So we are just reusing the existing order Kafka producer, which is acknowledgement is equals to all, which is already there in the code base. Now what we are doing, order Kafka.send. Again, we are sending through the producer record. The topic name, the key, the value. The topic name, the key, the value. What doesn't need touching at all is we don't need to touch the order header events, order item events, delivery partner location events, their schemas, their topics, their partition counts. None of these changes. Restaurant dashboard consumer keeps running exactly as it was. Still subscribe to only those 2 topics. Okay, I hope this is clear. So now a lot of time I have taken this name topics. Now let's understand what is topic. So topic is nothing but a name. The same way there is a YouTube channel. Let's say there is a YouTube channel which will be having multiple playlists. As of mine, I'll be having a Kafka playlist and an LLD playlist. So the topic is just like a playlist name. So whatever videos that is related to this Kafka will land in this Kafka playlist. Whatever videos that will lie or that will be related to the LLD, which will be landing on the LLD playlist. The same way YouTube channel is named as Kafka Tutorials. It's not a video, not a server, not a file. It's just a label that groups related uploads together so people know where to find them. I hope this topic is clear. Now let's see the sequence of Kafka, what Kafka follows. So the first step is the topic is decided first by the developer. The developer, while creating the topic, they decide the name, okay, before any data is ever sent. And the Kafka figures out the partitions. The topic will be decided by the developer. The partitions also will be decided by the developer, but which partition the topic will go will be decided by the Kafka. And only after that the broker event get relevant. What is broker? Broker is nothing but a Kafka instance of Kafka server, because the broker is just wherever the chosen partition happens to physically live. I hope this is clear. Now we'll be moving. Developer picks topic name in code ahead of time. Producer sends a record. Now what will happen? Kafka picks a partition for it by this formula. Okay, there are separate algorithms, like there are round robin, there are this formula and many more things by which a partition gets selected. That partition lives on some broker and the data lands there. Now the entire reason to create 6 partitions in the first place is spreading load across multiple brokers for parallelism. Now, hashing the key to select the partition solves 2 different problems. Different keys spread out across different partitions. So all 6 partitions actually get used. Let's say we have 1, 2, 3, 4, 5 and 6. These all keys will land into different partitions. All 6 partitions are getting utilized. Now, same key always produces the same hash. Let's say there is 4. The hash of 4 will be x4. Let's say, for example, so when in future the ID 4 will come, it will always give x4. If it is x4, it will lie in the same partition. So what will happen? So it always lands on the same partition, which is exactly what gives you per key ordering. Okay, every message for supplier ID 42 always land on the same partition in the order it was sent. So now sending the message. Sending the message has 3 different ways. The first one is the fire and forget. It calls the producer.send with the record and moves on without checking the result. Okay, it just directly sends without caring about the result has sent or get delivered successfully or not. Why? Because of this reason, that Kafka's highly availability and atomic retries mechanism means this always gets succeeded. If not always, usually this gets succeeded. Fire and forget method is getting used to send the message, but sometimes the non-retriable errors lost silently. Now moving to the second way by which we can send the message. So producer.send record.get. This is the main idea. It blocks the calling thread until the broker replies. This .get will wait for the result or for the acknowledgement to get before it proceeds. Broker response time ranges from 2 milliseconds to several seconds. Until then, the thread does nothing else during that window, not even queue the next message, until and unless this will get the acknowledgement that the broker has successfully get the response. This is not going to do anything. Okay, now let's move to second. Okay, so for example, what we are doing, new producer record, we are passing the topic, we are passing the key, we are passing the value. We are doing producer.send, the data we are passing, and .get. Okay, this is the code example. The third way is the asynchronous send with a callback. It returns immediately like fire and forget, but still surfaces error. Okay, why? Surfaces error means if something goes wrong, you get told about it. It doesn't fall silently. This is the callback that we are sending along with the record in order to achieve this asynchronous send with a callback. Why? Let us understand. So this line get executed before end. This is just a simple system.out.println before send. When this line execute, it will not wait for the complete process that will happen. This line executes. As soon as this line executes, this line will be executing after send. The prints almost immediately gets executed, which is it will print after send. This prints almost immediately. Now what is the reason? So the send println runs right away. Send println runs right away, typically before the broker has even received the record. means this line gets executed even if the broker has not get the response or all the operations has not yet performed. This line will get executed. Send doesn't wait for anything, it hands the record off to an internal in memory. It will not wait for anyone or anything. Batch and returns control back to your code instantly. Okay, it will return control back to our code instantly. So what is the main agenda of calling this callback? So when does this callback is getting called? Now let's see this. So not as a part of line executing. Okay, when the line gets executed, it not gets called. Okay, this callback is not gets called as a part of this line execution. It runs later when a background thread inside Kafka Producer, the one batches a record and ships them to the broker. Batches a record, I hope this is clear. Ships them to the broker, I hope this is clear. So actually get a response that could be few milliseconds later, and it happens on a background thread, not the thread that calls the send. Okay, so there are two threads that are being utilized. So the first one is the one that is actually calling the send, but the callback is getting called with some other thread. So we never created that thread ourselves. It already exists inside the Kafka Producer object the moment we constructed it, and it's what quietly doing the waiting on our behalf of the side while our own code keeps running. So one thread is actually calling the send. It will not wait for anybody. It will straightly jump to the second println statement. The background thread is what quietly doing the waiting on our behalf of this side while our own code keeps running. So this is the whole picture of asynchronous call with a callback. Fire and forget simply sends. Synchronous sends and wait, thread blocked until the broker replies, 2 milliseconds to some seconds. Okay, asynchronous callback is thread free. Callback fires later on sender thread. Now let's understand about this acknowledgement. This property we have seen while creating the producer, what actually it is. So it controls how many replicas must confirm a write before the producer treats it as successful. The whole logic of creating two producer was this acknowledgement. We have created the order producer which will be having the acknowledgement is equal to all. We have created the delivery location producer which is having the acknowledgement is equal to 1. So acknowledgement is equal to 0 means it doesn't wait for anything to get replied so that it can move forward. Okay, acknowledgement is equal to 1 means wait for the partition leader. Every partition have the leader which is leading that partitions. If the leader crashes immediately after replying and before replicating, what does this mean? Let's say the message is getting sent to the leader. The leader crashes immediately after replying. The leader has replied that it got the message. Okay, but the leader needs to replicate this message in order to be on the safer side, that if in future the leader gets down, the message can be taken from these two brokers or these two replicas. But what happens whenever the message gets replicated to the leader has sent the response, okay, I get it. But before replicating to multiple replicas, if the leader dies, then there is a chance that the message can still be lost. Okay, if we are putting acknowledgement is equals to 1. I hope this is clear. Now, if we are putting acknowledgement is equals to all, there is a small catch, or there is the understanding difference. When we say all, it doesn't mean that there is a leader which is having 4 replicas. All doesn't mean that you will be getting response from all the 4 irrespective of this is not available at the current moment, this is not available at the current moment, these 2 are available, then all is considered as in sync replicas. These 2 are known as in sync replicas. If 2 replicas are not available, they will not wait for these to send the message as a acknowledgement that okay, I have received. So the statement states here is waits for every in sync replica. This is the safest mode and it's default there in Kafka. So it only waits for replicas currently in that in sync list. In sync list means whatever I have explained just now, not for every replica that technically exists. Okay, so if a partition has 3 replicas but one is lagging, if a partition has 3 replicas and one is lagging, so acknowledgement all means it waits for the leader plus 1 replica. Okay, let's say if the leader has 3 replicas, 1, 2 and 3. If it has 3 replicas, so it will not wait for the lagging one. Instead, leader plus 1 replica. That's actually, I hope till here it is clear. Now let's see some of the delivery timings and throughput configuration that we have in Kafka. So the first config is max.block.ms. It caps how long this send this send itself can block. This happens when the send buffer is full or the metadata isn't yet available. Now, what is the point of having this configuration? So the whole point of having this configuration is, let's say we are invoking the send method, but if the send buffer is full and if the metadata is not yet available, do we need to wait infinitely for the send to get executed? No. With this configuration, we'll see that how many milliseconds we need to wait for the send to get executed. If it not gets executed, we'll leave it. So that is the whole point of having max.block.ms. What is the point of having delivery timeout.ms? Is the full budget from the moment a record is batched. A record is batched to the moment the broker confirms or the client gives up that, okay, I have got the message. So this is the delivery timeout.ms. Now request timeout.ms. It bounds how long the producer wait for a reply to a specific request. Okay, it waits for one reply to come. It will wait for a certain milliseconds or certain seconds that, okay, I'm waiting till 3 seconds. Meanwhile, you can give the response that you have reached the message or you have got the message. Okay, this is the whole point of having this request timeout.ms. Now this is the most important, linger.ms. Now it controls how long the producer waits for more records to join a batch before sending, even if the batch isn't full. Let's say the 4 message is sent by the producer. Producer.send, producer.send, producer.send. Now what we'll do, we'll check the linger.milliseconds. For the 3 seconds, for 3 seconds interval, I'll wait and I'll batch all the messages that will lead to one partition. Let's say all partitions, all ID is 42. Okay, so I'll batch for 3 seconds. Okay, this got batched, this got batched, this got batched, this got batched, and this got batched. Still there are some spaces left in the batch size. Okay, but it will not wait more than the linger.ms time. Okay, so the same thing is saying it controls how long the producer waits for more records to join a batch before sending, even if the batch isn't full. Even if the batch isn't full or the batch have more capacity to take the message or join the message, it will rely on the linger.ms. Okay, I hope this is clear. Now the practical approach is to, if you're talking about the delivery timeout millisecond, the total budget includes every retry, the whole process. Okay, the whole process. So the ideal way to give the timing is measure how long the cluster takes to recover from a broker crash. Let's say the broker crashed. Okay, so how long it takes to recover? Usually the leader election, whenever the broker gets recovered, this is the leader election happens. Who will lead the partitions or the broker? So leader election typically takes 30 seconds. So set the delivery timeout milliseconds above around 2 minutes. That is the safest config we can do. Now moving to the max in-flight request per second. What does this mean? So it's how many batches of messages a producer is allowed to have sent but not yet confirmed. Let me read this line and you'll be clear. So think of it like sending letters before getting reply for each one. So it's not efficient that for every message I'll send, I'll wait for the reply. I'll send, I'll wait for the reply. So instead of sending letter 1, waiting for the reply, then sending letter 2, waiting for the reply, we'll send up to 4 letters back to back without waiting and replies come after. So this is the importance of this configuration. So max in-flight request per connections. It's how many batches of messages a producer is allowed to have before getting a reply. Okay, it's not like I'll send this message, wait for the reply, this message, wait for the reply, this message, wait for the reply. No, I'll send back to back 5 letters and then reply will come afterwards. Now let's move to the ordering and idempotence, what actually it is. So Kafka preserves order within a partition. That is, if you haven't watched my first video of Kafka, please go and watch. In that video, I have done a detailed explanation of all these things with a proper example of WhatsApp. Now, Kafka preserves order within a partition, not across partitions, with retries greater than 0 and max in-flight request per connection greater than 1. With retries greater than 0 and this config greater than 1. Okay, a retried batch can land after a batch that succeeded on first try. Let me explain you. Okay, let me explain you. Reversing, what is the consequence? It reversing the order they were sent in. Okay, what will happen? Let's say a broker receives a record. Okay, a broker has received a record. It writes to the disk and replicate it successfully to followers. Okay, so a broker has receives a record, writes it to the disk and replicate successfully to all their followers. Now then the broker gets crashed. Before sending the reply that I have received, the broker gets crashed. Now what will happen? The producer hearing nothing within the request timeout milliseconds. The request timeout milliseconds retries, the retry lands on a new leader. Let's say whatever example that I have given, the broker receives a record, it has written to their followers, and before sending the response, it gets crashed. Now the producer will wait for the request.timeout.milliseconds, and if it not gets the response, it will again send. And send it to the broker. Let's say meanwhile the broker gets activated, or some another broker. Then the problem is the retry lands on a new leader which already has the record from the completed replication. Now it's a duplicate. Okay, did you understand how the data gets duplicated? So did you understand why these many configurations are there? How many use cases are there? How we can solve those problems with the help of these configurations? So there is this configuration which is enable idempotence is equal to true. What this configuration says, it fixes two problems. So every record carries a sequence number. Okay, did you understand? So every record carries a sequence number. The broker recognizes a repeated sequence number and drops the duplicate instead of writing it twice. If we send every data with the sequence number, then the duplicate data problems will be solved, the first thing, and while the ordering is also preserved within up to 5 in-flight requests. Okay, the two problems that is solved by this configuration. I hope till here it is clear. So by default, the thing is maxed in-flight customers connection is less than equal to 5, retries is greater than 0, and acknowledgement is equal to all. This is the by default Kafka configuration. Now without idempotence, the risk of reordering, let's say the batch A fails, the batch B sent, the batch B gets okay, A retried. Can you see? The intent of the producer is to send the batch A, then the batch B. What actually we have? The batch B got okay and the batch A got later, okay, which we don't want. So we'll be sending it in a sequence. A got sequence 1, B got sequence 2, broker checks sequence, and the write in order sequence 1 and sequence 2. Okay, I hope this is clear. Now let's see some of the jargons of this Kafka. So along with the message, we'll be sending the headers. So it is the extra tags attached to a message which separate from the key and value. Now it is used to note where data is coming from or to help route a message without opening and reading it. Header is just like a metadata. Now let's understand what is interceptors. So interceptors is nothing but if we want a certain part to get executed before the main execution, or we want the certain part to get executed after the execution. On that use case, interceptor is getting helpful. So the code that runs automatically right before the message is sent or right after the reply comes back, without actually editing the producer code. That is can be achieved with the help of interceptors. Now what is quotas and throttling? So the brokers can cap how much data a client can send or receive per second. There are 5 microservices and there is one broker. Every microservice is sending to the broker. Okay, it's not like broker has the capacity to tolerate each and every message. So what quotas and throttling do is, so it decides how much the broker time can be consumed by every microservices, okay, or every producer, okay, going over the limit. And what will happen? The broker doesn't reject you. Let's say taking the same example of 3 microservices and one broker, everyone is sending the message, and if it is getting over limited and again sending all the messages, the broker won't reject, okay, the broker won't reject, but it gets slowed down. So it just replies slower, and if throughput drops for no clear reason, check quotas first. Okay, I hope this quotas and throttling is also clear in Kafka. Okay, now let's understand about this Kafka cluster which I have used on the first page. What is Kafka cluster? A group of multiple Kafka broker servers working together as a unified messaging system. This is the Kafka cluster. Now let's understand the components inside the cluster. We have the broker. I have already explained. It is an individual Kafka server instance. Okay, a cluster typically has 3+ brokers for fault tolerance. Okay, each broker has an ID and store data on disk. This is what broker is. Topic, I have already explained. It's just a naming given where messaging are published. Partitions, already explained. Each topic is split into partitions and partitions are distributed across brokers. This is how Kafka achieves parallelism and scalability. What is replicas? So every partition can have copies on multiple brokers. Every partition can have replicas on multiple brokers. Let's say partition 1 have replica on broker 1 and broker 4. Okay, this is the example. So one broker is the leader for partition. So for partition 1, let's say we have data on broker 1 and broker 3 and broker 4. So one will be the leader and the other will be the follower. If leader dies, this one will be promoted to the leader. Okay, so what it is saying, one broker is the leader for partition. It handles all reads and writes. Others are followers. Okay, just replicate data, ready to take over if leader dies. Okay, I hope this is clear. Now let's see the controller. So if one broker in the cluster is elected as the controller, it manages partition leaderships, detect broker failures. So one broker in the cluster will be elected as a controller. It manages the partitions and it detects broker failures. So let's see three things how it can be achieved. Scalability, how it is getting achieved? By partitions spread across brokers. Okay, partition 1 will be spread across multiple brokers. So more throughput. If one is down, we get the response from another broker. How fault tolerance is achieved? Replicas on other brokers. Same thing. Let's say P1 is on broker 1, broker 2, broker 3. Okay. So fault tolerance means if one broker is down, we can have data from broker 2, broker 3. So this solves throughput also. This solves fault tolerance also. How this is high availability? If a leader broker dies, a follower is promoted automatically. Same as here. Okay, replicas. That's the whole point of making the replicas. So if the leader broker dies, a follower is promoted automatically. That's why we have achieved the high availability. So these are the three reasons that is getting achieved, and I have explained you the reasons. So I hope I was able to explain each and everything that I have mentioned, that I'll be explaining in this video. And I hope I was able to make it clear for you all to understand what Kafka Producer is, what are the configuration that we have, and how Kafka works. So that is it for the video. So next video will be going to be all about the Kafka consumers. Okay. So till then, thank you so much for watching and having patience. See you guys in the next video. So thank you.